Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
So let's answer some questions about separating mixtures. So first we have, how do we tend to separate mixtures? Well, we've got to use the different properties of our substances. So that could be whether they're soluble or insoluble, or it could be differences in things like their boiling point. So we can change the state of the substances sometimes to help us separate them. And why do we use one technique over another? Well, we're going to use the simplest one we can that gets the job done, essentially. So something like sand and water, we could evaporate off the water and be left with the sand, but actually filtering is much easier in this case and it's going to waste less energy. Okay, so let's have a go at a practical question here. How are we going to separate a mixture of sand, salt, water, and ethanol? Well, we need to look at the different properties of these things. So here's one. Sand and salt, one is insoluble, sand, it doesn't dissolve, and the other is soluble in this mixture. So the first thing that we could do is some filtration, okay, so that I can remove the sand from this mixture of these four different substances. Then I'm going to have to use fractional distillation. So because ethanol has a lower boiling point than water, what you will get here is your ethanol will evaporate and condense, so we can separate it out that way, and then your water will evaporate and condense. So you get, in this sense, your salt being left behind. Now, the order in which we did this was quite important, because if we'd started with the fractional distillation first, then we'd actually have ended up being left with a mixture of two solids, with a mixture of the sand and the salt, and that is actually quite hard to separate. So it's important we did the filtration first and then the fractional distillation afterwards. Okay, now chromatography. Calculate the RF value for the substance in C given the following chromatogram. So you've got the picture there, you've got the start line, you've got the paper, and you've got the solvent line. So you need to look at the distances that things have travelled here. The solvent has travelled 10 centimetres, and the only spot in substance C has travelled 2 centimetres. So my RF value, remember, is basically just a ratio. So it's the distance that the spot travels over the distance that the solvent has travelled. So in this case, the spot travelled 2 and the solvent travelled 10. So 2 over 10 is 0.2. And we don't have any units for the RF values. So do any of the initial mixtures contain the same substances here? So yes, they do. If we look at substance X, it actually contains both substance C and substance B. And how do I know that? I know that because their RF values would be the same, or in other words, C travelled the same amount as that first little dot in X, and B travelled the same amount, kind of 8 centimetres, as that second dot in X. Remember how far these spots actually move up the piece of paper depends on a couple of things. It depends on how soluble they are and how attracted they are to the paper. So the less attracted they are to the paper and the more soluble they are in that particular substance, the farther the dots will travel here. You can also use these things to check whether your substance is pure or not. So a pure substance, you won't get more than one dot, like, for example, substance C here. But an impure substance, like substance X, which is a mixture, you will get it separated out into those 2 dots that you see along the X kind of column there.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, some tips and tricks for this section. So firstly, in order to be able to choose an appropriate method to separate substances, actually you need to be really hot on your knowledge of structure and bonding so that you could decide what states of matter these different substances are in, because that is going to affect which procedure you choose to separate the substances. RF value that's greater than 1 can't happen. So if you get an RF value that is greater than 1, check you're working. Most likely you've got it the wrong way round. You've got the distance of the solvent divided by the distance travelled by the spot. Okay, so that would be the wrong way round. So it's the distance of the spot divided by the distance travelled by the solvent. Okay, and finally, we have the stationary phase is the paper and the mobile phase is the solvent here. So don't be confused by these two terms.